Welcome! In this video, we will explore the derivation of the ellipse equation. First, let's look at an ellipse centered at the origin. Here we have the center point at 0, 0. The horizontal axis is the major axis with length a, and the vertical axis is the minor axis with length b. Now, let's mark the foci of the ellipse. They are located at plus and minus c along the horizontal axis. Consider a point on the ellipse. From this point, we can draw lines to each focus. Let's call the distance from the point to the right focus alpha 1, and the distance to the left focus alpha 2. A key property of an ellipse is that the sum of these two distances, alpha 1 plus alpha 2, equals twice the semi-major axis a. Next, we apply the distance formula. The distance between any 2 points is the square root of the difference in x-coordinates squared plus the difference in y-coordinates squared. Applying this formula to alpha 1 and alpha 2 gives us their expressions in terms of x, y, and c. Now, we have an equation that says the square root of x minus c squared plus y squared plus the square root of x plus c squared plus y squared equals 2a. To simplify this equation, we square both sides, expand, simplify terms, divide, and then square again. We continue with some algebraic manipulations to isolate terms. You can pause the video here and work through these steps carefully by yourself. After all these steps, we finally reach the canonical form of the ellipse equation. It reads, x squared over a squared plus y squared over a squared minus c squared equals 1. If we set x equal to 0 and y equal to b, we find that b squared equals a squared minus c squared. Substituting this into our equation gives the familiar form. X squared over a squared plus y squared over b squared equals 1.